Good morning. Okay, this morning I'll be taking you guys through topic introduction to model view controllers. MVC. You already know my name. My name is Obinna. And okay, I, I, so basically this will be an introductory version of this presentation and subsequent presentations come. I believe for most developers, basically this topic won't be new to them. And for others, I hope this presentation actually sets our minds to the basic, to the beginner's understanding of model view controllers. So this morning I'll be highlighting, these are basically the highlights, and I'll be going through an introduction. I'll be giving you guys a brief history of MVCs. And I'll be sharing with you guys the components of MVCs, what the functions of the model, the view, the controllers, the workflow. Basically, this is actually my highlight. So introductions. What is actually a model view controller? So model view controller, or MVC as it is popularly known as, is actually a software design pattern or a structure basically for developing web applications. MVC is one of the three programming models developed by ASP.NET. ASP.NET is actually an acronym for Active Server Pages, which is actually a Microsoft product, and it is actually developed to replace the .NET programming language or framework that was already in existence. So it's just MVC basically is just a pattern or a structure which is designed to actually separate or relieve dependencies on the models, the interface, and the controller. So basically what it does is just separates the model, the user interface, and the control logic of an application into three distinct components. So I'll be just going through the history of how it was actually originated. So MVC was actually presented first by, I don't really know how to pronounce this, but I'll try to call it. So that was actually presented by that guy in 1979, and it was later introduced commercially in Smalltalk frameworks in 1987. So we're actually living in an era of application home. So MVC happens to fit well with the internet in the sense that it's capable of executing actions in the controller, which is actually on the server side. And it also communicates with the data on our database via the model, and also communicates with the view on the client side. Sorry for the non-developers, this might actually be sounding a bit strange, but I hope to carry them along. So what are the components of MVC? MVC can actually be categorized into three components, which are clearly displayed on our screens, and they are models, views, and so we're basically looking at the functions of what all these components actually represent, or what they actually do. So we'll start first with models. What are the functions of the model component? So model component is actually starting with the responsibility of managing data of the application. And basically the data is actually stored on our database. So what the model does is just gives a holistic, in the form of a management, a general management of our data on our database. So the data is actually responsible for responding to requests from viewers, which are actually the users. And also, and these requests are actually user actions which are basically instructions from controller which communicates to the model to update the current state of the model. The model represents the application code in the sense that it offers a specific representation of information with which the system operates. So this is basically just what the model does, and I'll be giving you guys an overview of what the three components do. So the view. So the view represents the model in a suitable format. Actually, the view is actually our graphical user interface, like our desktop and model. What can actually communicate to the database or the app or the system. So the view is just basically a GUI, the graphical user interface that actually helps us communicate with the database. So basically represents the model in a suitable format in a way that it interacts and have access to the database. So the view actually requests information from the model that it needs to generate an output representative. So for instance, you can actually say we want to actually log in or register. So what the view does is it requests information, it tells the model, yeah, this person is actually a registered user. So gets the info, is login information from the database. And actually how it does that is actually it sends an action to the controller and the controller communicates to the model and the model actually displays the output for us. Here the view. So the view actually represents, it's just not just graphical, it actually it's not just the HTML that I explained earlier, or I placed with brackets. It's not about just displaying HTML tags and CSS tags. It's also about it represents particular data formats like PHP, Python, JavaScript, and the rest. So we're looking at the controller and what the controller does. So the controller actually is a link between the view and the model. It is responsible for receiving and responding to events. Events are actually clickable actions from our systems, from our laptops, and all that. So it actually responds to those events and typically uses actions to evoke changes on the model and probably. So typically controllers read data from a view, gets in what the user wants, and it says it controls the user input and sends that user input to the data to actually fetch particular data that the user is actually looking for. So basically, this is a general workflow overview of what I've been saying since. So this just tells us this basically user can be anybody. So the user sees the view can be on our system, on our monitors, on our desktop. So he sees the view and he clicks on it. He actually clicks on an event. He actually makes an event call. And that event call is actually an action. So the action actually takes place on the controller, and the controller tries to manipulate that action the user have actually sent in to the model to actually fetch that model, and the model returns the updated version of the user's action and displays it on the screen for us to actually see what the user is actually doing. So this basically is just a general kind of overview workflow of what the view model controller does. So the user first interacts with the view component correlated to the controller now interacts with the model now gets fetched. The controller fetch the data via the model and displays it to the view for users to actually see. So this is just a breakdown of the previous slide, what we call the control flow. Just a breakdown of the previous slide, the workflow as well. And though the MVC approach is actually being adopted by different frameworks like PHP, But yes, it still possesses the same control flow, and this can actually be elaborated further. So the user, so this is just basically going over what I said in the previous slide. So the user interacts with the view, that is the user interface, can be our laptop. And in some way, the user actually clicks an event, that means he uses the button, actually clicks on an event, he clicks on something, it can be anything on the screen that he wants. So the controller handles that input effects from the user via the user interface, the graphic user interface, and often via and actually via the user interface, or actually a registered handler or a callback function that is attached to that action that the user has actually clicked. The controller assesses the model, possibly updating it in the appropriate way to suit what the user has actually requested for. E.g., the controller updates user shopping cart. You can actually change your status from being a premium user to another user. So what the controller does is actually, yeah, you want to change your status. So it takes that action and tries to manipulate and gets the data from the model. The data, that means you're changing from one status to another. So it gets that action, that data action from the database and displays it and brings it back to the different user. So that's what the controller does for us. So after that, it actually generates a new view, and the view takes data. Then basically the user interface actually waits for another action, another clickable event to actually occur, and it starts a new cycle. There are some dependencies. These components I just mentioned actually interlink. They actually have this dependency, but not all anyway. But they actually have this correlation and that actually interlinked in a way. But some are actually highly dependent from the rest. So I'll just mention a few. The model knows only about itself. That means it has the source code, the blueprint of the database, and it has no references to either the view or controller. The view, however, knows about the model. It polls the model about the state, about the current state, to know what to display. So when the view actually reacts and communicates to the model via the controller. So what this is saying is that the view knows about the controller because it actually thinks that's what actually displays what the user is actually seeing on the screen, but in a better way. So they depose the model about the state or about the state to know what to display, but the view knows nothing about the controller. So the controller, on the other hand, actually knows about the model and the view. For example, from a game, if you click on the fire button on the mouse, the controller actually knows which action to actually call to perform that fire button already. So that's what the controller is actually saying. It knows about both the model and the view because it actually gets info from the view and tries to manipulate the model. So it has a link, it's actually a link between the model and the view. So the benefits of this correlation between these components are summarized below. No matter how the view class is modified, no matter how you try to click on another event, you cannot change the state of the model. That means the model still retains its original state and it will still function properly. Also, if the system is moved from the desktop operating system to any other operating system on your smartphones, the model can actually be moved without no change. It's just the database. The model is actually communicating with the database. The database is somehow fixed, so it doesn't really change as much. So, but the view probably needs to be updated with regards to the operating system that is being working on, it's being transferred to, as well as the controller needs to be updated. The actions in the controller needs to be updated. So basically, this is just the working of the MVC in web application in general. It starts with the user, which sits on the user of the view icon. It communicates, after a clickable event, it communicates with the controller through the graphical user interface content. And the user sees this action. And actually, he tries to communicate with the model, but the only way he actually can communicate with the model is via the browser. So he sends a response via the HTTP, the hypertext transfer protocol, to the browser. And the browser sends a request back to the controller, which he uses to manipulate the data if the user wants from the model. And the model returns back to the controller an arrays of resulting data based on the actions the user. So basically, this is just the structure of how, and it might not be the same for all the frameworks. But I just brought this here to actually show us how the structure looks like, an MVC structure actually looks like. So what this tells us, or what this shows us, is just that you can actually see the controllers, the models, and the fields. So it just tries to simplify our work, our codes in a way. So the app is actually the parent folder that comprises of other folders like command config. So the config is actually database, but I don't want to go about it that, but what we're more concerned about is about the controllers, the database. So these are basically how MVC structure actually looks like in most of our frameworks. So the advantages of employing this kind of structure is that it gives you an organization. You can actually realize this from this kind of structure. You can actually know where the actions, where the controller is, the files in the controllers. You can actually know somebody at least a novice or somebody that is actually working parallel or alongside you. So you can actually know where to go to find files are relating to the controllers. Also, files are related to the models and to the view. So it creates a form of simplicity and a form of organization. So it clearly separates logic from presentation logic from business logic. So each object in the FEC has its own distinct responsibilities, like I've plenty enumerated in the previous slide. So they come with their own distinct responsibilities. So most of these codes found in our MVC structure are actually reusable codes that are easy to maintain and they aid future enhancements of these codes. So okay, parallel development in the sense that with such codes, some both different developers can actually be working on the same project, knowing fully well where to actually get particular codes relating to what they are looking for. So it aids parallel development for developing of web applications. So we're looking at the merits, and I'll start by increased complexity. You have to create folders for the controllers. You have to create folders for the controllers, models, and all that. So you have to have an in-depth skills. So for novice, basically, it increased complexity of their designs. But I think for me, this shouldn't be a disadvantage because of time. This shouldn't be worrying. This shouldn't be as difficult for somebody that is repeat experience. So it creates inefficiency of data access in the view. As you realize that the view actually communicates to the model via the controller. So the view doesn't have this direct link to the data in our database. So it has to pass through an intermediary, which is the controller, to actually get these data streams. So it actually creates an inefficiency of data for data assets from the difficult components. Difficult using MVC with other user interface too. Knowledge of multiple technologies, like your OOP and the rest. So when to actually use them, MVC can actually be used in all types of systems. This can be seen in Java, Python, Perl, most.